Before we can make the leap from arithmetic to algebra, there are a few concepts that are critical to understand. These concepts are variables, order of operations, and mathematics as a language. This video talks about mathematics as a language. Using arithmetic to build algebra requires an increased level of rigor in word choice and definitions. This means if you're unfamiliar with the precise definition and the context of when to apply it, it can get confusing quickly. This is similar to learning a new language. In English, words that have different meanings but are spelled or sound the same are called homophones. Bark, date, bat, park, and you can probably think of a lot more. Consider the phrase, "a loud bark echoed through the alleyway," or "dry bark is great for kindling a fire." Even though the spelling is the same, the context of these sentences provide the insight into which bark is being used. The first sentence is clearly an animal bark. The second phrase is the bark of a tree. Words with double meaning also show up in mathematics. Just like we become acclimated to double meanings with exposure, gaining experience with double meanings in math help provide additional insights. For example, the words and/or mean different things in English versus mathematics. You and a +1 are invited to the party. In English, this means you can come by yourself, both you and a +1 can come together, and though culturally questionable, it also means the +1 is likely invited by themselves. However, the mathematical meaning suggests you can attend if you have a +1. In other words, if you are by yourself, you are not invited to the party. Consider the following phrase instead. You or a +1 are invited to the party. In English, this means either you can come or the +1 can come, but not both. Given cultural norms and context, we would likely toss it up to a typo. In mathematics, this means you can go by yourself, the +1 could go by themselves, or both together. As you can imagine, this gets extra confusing in word problems like the following. Susan and George buy 36 watermelons. George takes 4 times more than Susan. If Susan takes 20 watermelons, how many watermelons does George have? Ignoring the questionable watermelon purchase, having just mentioned the and/or English differences, it's easy to get caught up in the question of, did they buy 36 watermelons in total, or 36 each? This means there are 2 possible outcomes to this question. One where 36 total, and another where 2 times 36 is 72 in total. Knowing which one is meant comes down to the context of the question and resolving any potential ambiguities. These types of issues arise in English language as well. For example, the sentence, "I'll wait for you by the bank." Is this the financial institution or the river? We need more context before we can definitively say which bank is intended. It also requires us to be aware of both meanings to recognize the ambiguity. People that come up with word problems are not perfect and cannot predict how every individual interprets specific words. This means there are frequently English to math translation typos that complicate word problems. Generally speaking, if there is an ambiguity in the question, ask the teacher for clarity. In math class today, the curriculum expects teachers to bridge the gap between the double meanings. In my experience, it seems most would benefit from a specific course on navigating mathematical language. Unfortunately, that is outside the scope of this course. If there is significant interest in the topic, I can consider creating a course later. Regardless, someone learning math for the first time will need to navigate the language just as much as they will need to navigate the concepts themselves. Remember to do your best and show your work. If possible, argue your case when ambiguity arises. Most math teachers understand language introduces ambiguity problems.